all these balloons on your table. I bet you're demonstrating heat transfer. And there's something special about the balloon on your table. It's got a little bit of water. If you look really carefully, you can see a water line. And underneath it, it has a candle. We want to find out what happens when you put a balloon with a little bit of water over an open flame. Will it pop if there's a little bit of water in that balloon? So I'm over here with my first team. And Mahalit, we're going to light the candle. You ready? We want to see what happens if it stays inflated or if it pops. Let's get really close. Mahalit, why isn't it popping? It should pop. You should have water all over you by now. Where's the heat going? Erica, where do you think the heat is going if it's not popping?
The water.
It's going to the water. So this is still heat transfer. Your candle is radiant heat, but it conducts from the balloon to the water, and that water is taking the heat away from the balloon. And it's not popping. Isn't that weird? Let's try another one. I'm over here with Kaden. And Kaden, let's see if your balloon pops or stays inflated. You ready, Kaden? Now, if it pops, you're going to get all wet, right? Let's see what happens. Now, we did this a minute ago with just a balloon filled with air, and it popped pretty quickly, probably within about, 3 seconds. So, Kaden, why doesn't the balloon pop?
Because there's nothing to suck it up. So while the heat is going to it, it's just getting...
Where does the heat go? Does it go to the balloon or to the water?
It goes to the water.
Right, and is that radiation, convection, or conduction?
Convection.
Well, convection is through a gas, but if it's solid to liquid, that's conduction. So yeah, so the flame is radiation, but when it goes from a solid to a liquid, that's still conduction. And I see your balloon isn't popping. Okay, let's come over here and let's test it again. One of these should pop. Don't you think one of these should pop? Ryan, Carol, don't you want to get all wet? No? All right, let's find out. We're gonna do another test here. In science, you want to test a hypothesis as many times as possible. So we're just going to keep testing this and see if we get the same results. So that's right underneath the balloon. I see this balloon has got a little water in it. It should have popped by now. So why do you think the balloon isn't popping?
Because the water absorbs the heat.
Right, the heat's traveling. It's transferring from the balloon to the water. In that first test, we just did it with a balloon with no water, and it popped pretty fast, didn't it? Mm-hmm. Okay. All right, I'm looking over here at my next team. Okay, what do you think, guys? Do you think the balloon is going to pop if we light a candle underneath it? What do you think?
Maybe.
Maybe? Diego says maybe. Okay. Let's find out, Diego. Well, first of all, let's put this right underneath it. Okay, so the candle's radiation, that's radiant heat. And then it's transferring to the balloon and then to the water. So, Gabby, when it transfers from the balloon to the water, what kind of heat transfer is that?
Conduction.
Yeah, that's conduction, exactly. And so, while you think that the balloon should pop, if that heat can move away from the balloon, that might explain why it's not popping. Let's go over here. Let's keep trying this. Let's keep testing it. I'm over here with Diego, Christiana, and Mariah. What do you think, Mariah? Do you think you're going to get wet?
No.
You've got your blanket to shield you, right?
Yeah.
Okay. All right, Christiana, you ready? Okay, I'm going to light it right underneath here. You sure you don't want to scoot back? Okay, here it comes. Let's see if that balloon pops. Let's see here. I can see the water level. I can see that fire is going right to the balloon. So, why do you think it hasn't popped yet?
Because all the heat goes into the balloon, and then the heat of the balloon goes to the water.
Okay, so it's moving. The heat is transferring from the balloon to the water. What kind of heat transfer is that, Diego?
Conduction.
Yeah, that is conduction. Now, the candle there is also transferring heat. What kind of heat transfer is coming off the candle?
Radiation.
Yeah, that's radiation. So we got another balloon here that just refuses to pop. Let's come over here to Alden and Greg. Alden, you're kind of close to that balloon. You must want to get wet. You think it's gonna pop, Alden? You think okay? Alden doesn't think it's gonna pop. Let's find out. So we got the flame right underneath it. So Alden, why don't you think the balloon pops? Why won't it pop?
Because the heat's going into the water.
Yeah, it's traveling, isn't it? So when heat moves from a solid to a liquid, what kind of heat transfer is that?
Conduction.
Yeah, it's conductive heat. That's right. And it just won't pop. I've got another table over here. They've got a balloon. What do you think, Ava? Do you think that balloon will pop? Are you going to get water all over you? What do you think? Oh, she's scooting back. She's not sure. All right, Dylan, he's pretty close to it. Dylan, you have some faith that you're not going to get wet. Let's find out. Let's see if that heat travels from the balloon to the water. This is just an ordinary balloon. It just has a little bit of water in it. Doesn't seem to pop. So why do you think the balloon isn't popping?
I heard a hissing sound.
He heard a hissing sound,
I
okay.
thought, no, the water inside the balloon is absorbing all the heat and not letting it expand the balloon more.
Okay, so the water is taking the heat. So the heat moves from the flame to the balloon to the water. What kind of heat transfer is that from the balloon to the water?
Conduction.
That's conductive heat, right? What kind of heat transfer is the flame?
Radiation.
Good, Ava. Radiation. 6th graders learning about convection, conduction, and radiation just with a water balloon over a candle. Good job.